have covered function, not a function. Another way to say not a function is to call it a relation. Okay, remember in a function, x can't repeat. If it's not a function or if it's a relation, x repeats. And we have also covered domain, which is your x's, and range, which is your y values. All right, so how to find domain and range from ordered pairs. So if it's ordered pairs, it's just a list of numbers. Okay, so remember we have our squiggly brackets, and for example, we would have 0, 1, 2, 3, and so on. If you're on a graph, as long as it's a continuous graph, you would have your inequalities. And remember, for domain, you go left to right. Range, you go bottom to top. Okay. Also, if it's a open circle, it's less than or greater than. Closed circle, less than or equal, greater than or equal. Okay, express the relation, which is just a set of points, -2, -1, 3, 3, 4, 3, as a table and a mapping. State the domain and range. Determine whether the relation is a function or a relation. Okay, so we're just going to list out our x's. So I have -2, 3, and 4. Then we're going to list out our y's. So I have -1. Remember, you only write the 3 once. And then we are going to draw the arrows to the corresponding points. So -2 goes with -1, 3 goes with 3, 4 goes with 3. Okay, in a table, you write out everything, even the repeating ones. Okay, so since this was just a set of points, we're going to use our brackets. So we have -2, 3, 4 for the domain, because that's our x's. The range is y, and we just have two numbers in our range, -1 and 3. So if we're deciding function or relation, look at the x's. They don't repeat, so it is a function. All right, here we're determining the domain and range. So let's start with the x. So we're going to go left to right. So I'm going to box it in. So I find my point to the left. I have my inequalities. So it's at -3. It's an open circle, so I don't need the line. Then I find the point furthest to the right. That x value is 3. Again, open circle, no line. Then we're going to do the range. So it's an open circle at -5. So -5, no line. Open circle at 3. So 3 and no line. If I were to box this completely and shade, the whole graph would be covered, which is what you want. Okay, so domain. So point to the left is at -5. It's shaded in, so I need a line. Point to the right is at 4. It's shaded in. I need the line. Then we're going to go to our range. Bottom is a circle. It's at -5 and it's shaded in. so I need the line. Now I need to go all the way to the top. It might not be a circle there. So remember, if we draw the point, it's shaded in. So that's at 5, and I need the line. Okay, domain. So left to right. Here, I'm not going to draw the inequalities because I see arrows at both ends. Remember, arrows at both ends mean all real numbers. Same thing, bottom to top. There's arrows at both ends, all real numbers. Okay, here we are just determining whether each of the following is a function or a relation. So we're looking at the x values. On this first one, it is not a function, which means it is just a relation. On this one, since the 5 repeats, it's not a function, so it is a relation. Okay, on this one, none of the x's repeat, so it is a function. Remember, here you do the vertical line test. So if I were to draw vertical lines, each vertical line only touches my graph one time, so that makes that one a function. Here, it would touch more than once because it touches here and here on that same vertical line. So that is a relation. Okay, explain the difference between discrete and continuous. So discrete is something that can be counted. So it's going to be your whole numbers. Okay, and remember, on a graph, discrete is just points. Continuous is something that can be measured. So it can have fractions or decimals. And remember, a continuous graph, your points are going to be connected. So we're going to determine whether each of the following would have a graph that is discrete or continuous. So the total cost y of buying X amount of avocados. So you're not going to buy half of an avocado, so that's going to be discrete because I'm going to count how many avocados I have to find the cost. The number of birds in pet stores, that's also discrete. Total height of a giraffe, I measure height, so that's continuous. Total distance ridden on a motorcycle, I measure distance, so that's also continuous. Okay. The total distance for traveling to an away varsity Jaguar football game can be found using the function y equals 10x plus 15, where x is the number of miles driven. If most students drive between 9 and 16 miles, find the domain and range. So before we find domain and range, we need to decide, is it discrete or is it continuous? So since we're talking about miles, we measure that. So this is going to be continuous, which means I'm going to have inequalities for my domain and range. Okay, so for the domain, I'm going to go ahead and set up my inequalities. Okay, it tells me 9 and 16 miles. Those are my x values. So 9 would be the smallest, 16 would be the furthest that you drive. So to find the range, go ahead and put the lines. We are plugging in the x values into the equation. So we have 10 times 9 plus 15, and then 10 times 16 plus 15. So 10 times 9 plus 15 is 105. 10 times 16 plus 15 is 175. So we're going to have from 105 to 175. Okay. Student Council is selling Halloween candy bags. They are using the formula y equals 2.5x to determine y, the profit earned for x bags of candy sold. They have to sell between 55 and 60 candy bags to meet their goal. Find the domain and range. So this situation is discrete because we are counting the number of bags of candy we sell. So it's going to be our brackets with the list of numbers inside. Okay, so the domain, it tells me that X is my bags of candy sold, and I know we have to sell between 55 and 60. So my domain is going to be 55, 56, 57, 58, 59, and 60. Okay, my range is going to be the cost at those points. So all we would have to do is 2.5 times 55, which is 137.50. 2.5 times 56, which is 140. 2.5 times 57, which is 142.5. 2.5 times 58, which is 145. 2.5 times 59, which is 147.5. And then 2.5 times 60, which is 150. You can also just add 2.5 each time because that's what's happening.